This conference will now be recorded.
So chemical dilution method and hydraulic structure method. So this chemical dilution method is what it is just based on the law of, we can say, continuity equation. What they do actually here, suppose there are the river is flowing, right? So this river is flowing. So what they do, they take one section, suppose this section 1 and section 2. From here, section 1, they uh, the person who take this who do this test, what they do, they mix some chemical, and this concentration of chemical, say this is C0, and whatever the discharge is, say Q0, right? And after that, they at section 2 they collect the sample and they take what is the concentration here, so they note this concentration of, see, this concentration means there is some liquid, that may be some chemical maybe, or some ink may be there, and just they note down the concentration of that ink, means when it is mixed with water, so here obviously the concentration will be more, and when it will flow and it will come up to this section, the concentration will be something different, right? C1. So the discharge, they measure the discharge at, say this is C0 and here it is Q1. Discharge is Q0, here it is Q1. So it is assumed that the discharge multiplied by this concentration will be equal to the discharge multiplied by the discharge at section 2 multiplied by the concentration collected at section 2, that is C1 into Q1. If it is equal, so likewise, this chemical dilution method is used generally. This is not, we can say, nowadays this is not used, but this is one of the method. Now another method is the hydraulic structure method. This method generally it is very related with us. If we will see this method, so we measure the discharge at, we make some river or some artificial canals and we measure the discharge at that canal. So here, just I will tell you some more thing about this in something detail. Suppose, so again we have to go to the fluid mechanics and we have to see this, what is exactly that, right? So here, if you will see, there are different types of channels. For example, river is flowing, right? So we make some artificial channel. So this artificial channel may be made up of, artificial means that may be the rectangular, right? That may be the, say, V-shaped channel, means V-shaped channel is there and water is flowing with this. That may be the trapezoidal type of shape, right? And through this trapezoidal type shape, water is flowing, right? So what we do generally here, for rectangular shape or for V notch or for trapezoidal shapes, some discharge formula is given. This Q formula is given. Through this, only in this Q, we should have some dimension. We should have some uh, value of, then we can note down the directly discharge. So this is called as theoretical discharge, we can say. But through this method, we can calculate the discharge. For example, you see this formula is given as 2/3 of CD into L into H raised to power 3 by 2, right? If you will see this, I think it is visible to you, right? So what is this actually formula? So first of all, you remember that this formula is for rectangular notch. Rectangular notch. Just I will tell you. Yeah. Here, if I will zoom it, if you will see this, see, this is actually the artificial channel which is made up, and how much quantity of water here it is flowing, we don't know. What is Q? Q means this is in meter cube per second. So if it is rectangular, then there is a formula given. So if you will observe this is rectangular, right? This one and this one. This is what I want to show you. See, if we know that what is this length of this weir, and what is, suppose the height of water is up to here. So it is said that this is H, height of water. So then we can calculate how much quantity of water is flowing through this channel. Similarly, if you will see this is V type shape, right? V, or we can say this is rectangular, triangular shape, triangular shape. So just if we know that what is this angle, suppose this is V shape, right? And this will have some theta. If we know this theta, how much theta is this one, and what is the height of water which is flowing through this channel, so that then we can calculate the discharge. How we can calculate now? You will see this. So here the formula is given actually. So formula, what is this formula? So the formula says that Q is equal to 2/3 of CD into L into H. And this is for rectangular notch. What is rectangular notch or weir? What just we have seen this weir, right? This weir we have seen. This is suppose L length, and whatever the water is flowing through this. Suppose water height is from bottom to up to water surface. This is H. So simply we will put this value H. Suppose this is say 1 meter. So I will put the value here 1 meter, and the length of say this is 3 meter. So I will put here 3 meter. Right. Now, what is CD? CD is actually the coefficient of discharge. Here, the coefficient of discharge. Coefficient of discharge means the actual discharge upon theoretical discharge. So we get this CD values, and this CD value is already defined by various number of experiments for the rectangular notch, right? So we put this value CD, and we can calculate the discharge Q. So this is one of the method, that is hydraulic structure method. So we can calculate this discharge through this rectangular notch, or through triangular notch, or through trapezoidal notch. This trapezoidal like this, right? Now, again, this is one of the formula given for the trapezoidal notch. If you will see this, if our notch is trapezoidal, notch weir we can say, right? So this formula can be used for calculating the discharge through a trapezoidal notch. This trapezoidal notch. Trapezoidal means this type. So, and this trapezoidal is a combination of rectangle and triangle. So here you can see this is the rectangular portion, and these portions are what? This is triangular portion. So that's why the formula for this triangular and rectangular notch is added and we will get the discharge. So these are the methods through which we can calculate the discharge through some man-made structure. Is this okay now? So here you can see this the person you can also see here. So just see this is one of the structure made and here one pipe is given, right? And within this pipe they have made some artificial structure V shape V shape notch, right? So what they will do, they will measure the height of this. Uh, Suppose the water height is suppose here up to here from bottom. This height is h, right? So just they will calculate the height h and already if they know this theta, how much theta is, they will put the value in this formula here. So in this formula, this is triangular notch. Triangular notch formula is this theta means whatever the theta this one. Suppose this is started from 0 degree up to this one is say 30 degree or 45 degree. We will put here 45 degree. H is what? Water height of water which is flowing through that notch, height of water. We will put this value here. We know the G value is 9.81 and CD value is also fixed for the triangular notch. That is already we can find out. Means that is given already. Somewhere this value is fixed. That is given. So through this we can calculate the discharge, right? Is this okay now? Is it clear how we can measure the discharge through the artificial channel? Now, well, after that, measurement of water stage. See, what is this? We have to understand first what is what stage. Uh, for that, measurement of water stage. See, if you will see this, first of all, what is stage? Stage means it is, for example, stage means height. Stage means height. So height means from where? Height means from some reference level, some datum level. Suppose this line is as a datum level. This line is datum line. Stage datum or we can say datum line, right? Datum line. So with reference to this datum line, we measure the height of water here. So generally what happens, see, when flood occurs, flood occurs, we cannot measure the how much quantity of water is flowing, right? So generally, see, suppose this is the river. So first you understand this. What is the stage? Stage is the height from the datum level, and this datum level means this datum level is mean sea level. Mean sea level. From mean sea level, what is the height of water in the river, right? What is the height of water? That is H height. We can say height of water from mean sea level, that is called as the stage. Now, once it is clear what is stage, now you will see another this thing is given as cross-sectional area. Cross-sectional area means this one. This is the cross-sectional area. This is the cross-sectional area, right? So why this stage discharge is used? Why we use this stage discharge? Why this method is used? So first, now the definition is already here mentioned that water stage is the elevation above the some arbitrary datum or of the water surface at a station. For example, this height of water, this is very big river, right? What happens? Rainfall occur, right? Rainfall occur, and due to the rainfall, very heavy rainfall occurred here in this area, and the water level reached up to here. This water level is very big, right? We cannot measure through any like any instrument. Any instrument means just we cannot means when flood occurs, we cannot measure how much quantity of water has come, right? So in the flood case, what how we measure the discharge of the river? So what we do actually? So suppose our river is this natural river is there. So we fix one staff that is called as staff gauge. That is called as staff gauge, right? Suppose when rainfall was in the morning, rainfall occurred, then the water level was here. Then after say 24-hour water level come here in this river. Then again see after 2 days water level come here. So this discharge cannot measure just by going there. What we do here only we fix some height, that is staff gauge, or this is called as vertical staff, right? Vertical staff. And we just measure what is the height from here, from the this total height. Suppose there is fixed some height from mean sea level. So here maybe say mean sea level 300 meter, then this is maybe 400 meter likewise, right? Or 300 and say 50 meter, 50 meters is height, and again this is a 50 likewise. So we generally measure what is the height of water in the river, right? Height of water in the river, height of water in the river. We generally measure the height of water in the river only, right? This is called as the staff gauge. And water stage is what? That is the height of water from above some datum level. Is this clear? This one is clear? Yes. Mira, Salim, is this clear? Now, see, this is what? This is staff gauge. And it is not necessary or compulsory. We can fix only one staff gauge, right? Suppose this river is very having very high depth, and this cross-sectional area is also irregular. So what we do generally, the engineers, they fix one staff here, one staff here, one staff here. Likewise, when the water level will come here, or when water level will reach here, they will note down. When water level will reach here, they will note down the reading here, here, then at this level. So that is the one of the, we can say one of the gauge, that is this. If we fix more than one staff, then that is called as the sectional staff gauge, right? So only for just measuring the height of the water in the river. So here you will see that this diagram. So here there are the number of types of staff gauge. First, types of gauges measuring the river stage. River stage means measuring the river height of water in the river. So first, what is said, that is the staff gauge, that may be vertical or inclined, right? The second one is suspended or weightage gauge. What is this? This is what actually sometimes what happens here, we can say some rope, we can say, is suspended here, and this rope is inserted into the water depth, and then this depth is calculated, right? And how we calculate it? So generally, how much rotation, we note down the rotation, how much rotation is this one, and what is the diameter of the rope. And through this diameter and rotation, there is a formula through that we can calculate this depth, right? That is the suspended weightage, we can say, weight gauge. Next one is recording gauge. Recording means automatic recording gauge. We can say not only recording means automatic, we can say automatic recording gauge. Recording gauge. Automatic recording gauge is of two types, that is float gauge recorder or bubble gauge recorder. Again, it is of two types, float gauge, and bubble gauge. So all these are just remember that these are what? These are the gauges. These are just for measuring the height of the water in the river, these instruments. Then crest gauge is used to indicate the high water mark. So all these things are these are what? These are the stages for measuring the height of the water in the river. So some more diagrams are given here. See here what I discussed here. This is the one staff is fixed, staff gauge is fixed. Suppose what is the water level that is measured here. Suppose this is from mean sea level. What is this water level? So from mean sea level, there may be some sea, right? So from mean sea level, what is this height of water? We measure this. Similarly, what I talked just, and through this, once we know the height of the water, then see, now here the stage discharge relation. Just you see this graph. I will copy it. So what is this exactly? See here, what I told you. This is graph of discharge versus the stage for a given point on a stream, usually gauging station, where the stream discharge is measured across the stream channel with a flow water. For example, see, this is our whole area, right? Or we have already seen this is we call it as a water. This whole shape is called as watershed, right? Watershed, watershed. And here you will see one river is flowing, and within this river there are some small rivers are meeting, and whatever the water comes here in this area, so first they flow in these rivers, then they come in this main river, right? So this is our main river, and these are the small rivers. Suppose these rivers come here at this point. If you will see, the river is looking like this, right? This is at this point we have fixed the staff gauge, right? And simultaneously, see, suppose now what we do here, I'm talking about this graph, that is stage hydrograph. So at x-axis, we take the time, and on y-axis, we take the height or stage height, right? Or stage height of water, we can say, or a stage. Suppose at time t0, there was nothing, no, or very small height of water. Then after say 1 hour, then 2 hour, 3 hour, rainfall started, say 4 hour, 5 hour, and then say 6 hour. So at after 1 hour, the when rainfall started, the height of water has come here. Height of water has come here. Then after again 1 hour, height of water has come here, right? Then again after 1 hour, height of water has come here. Means this is at 1 hour, this is 2 hour, this is 3 hour, this is 4 hour. The height is increasing, right? So we just note down this height, and then a stage will come when rainfall will stop. The height of water will reduce and it will come at its own particular, we can say, its normal level. So we will see this graph will look like this. And when we will join this point, so this graph will be called as the stage hydrograph. Means on y-axis we are taking the height of water in the river, and on x-axis we are taking the time, and time versus height of water. When we are preparing the graph, that graph is called as the stage hydrograph. Is this okay? Is this okay? Stage hydrograph is okay. Now, there is one more term they are saying, stage discharge curve. So what is this? If you will see here, it was time. Now here it is Q. Means what? So in this, again, just assume this is our watershed, and this is the point where the water is collected. If we will see this point, there is that is the point of one point of the river, because the river is coming from somewhere, right? From here. Now river is reached at this point. So at this point, this is the cross section of the river. Cross section of river. Now at this point, we measure the discharge at water, that is discharge also, and height of water. So for example, at this height, the discharge Q is suppose say 1 meter cube per second. Then at another height, say this is Q2 or Q1. Say this is say 1, what I should say. So this is 10 meter cube. This is say 20 meter cube. This is third height is say 30 meter cube per second. Likewise, this is say. So once what we will do, we will take the discharge Q on x-axis and on y-axis the height, and again we will draw the one graph. So this graph will be called as stage discharge curve or rating curve, right? Stage discharge curve or rating curve. Now another is the normal hydrograph, which is generally used, that is discharge hydrograph. Means what? The same point, suppose this is my point and we are at this point. What happened, say here in this watershed, rainfall occurred. It is started from morning 8 a.m. or 7 a.m., right? Then after say 9, then 10, 11, 12, 13, 14, 15 means up to 15 p.m. Not just 15 only, we can say, and it means 3 p.m. This rainfall occurred. So at 8 a.m., what we will do at this point, what was the discharge? Discharge means, suppose this is my river and water is flowing from here. This is water. So we measure the Q, right? If suppose this Q is say 10 meter cube per second, then I will note down this as a 10 meter cube. Then at 9 o'clock, when the rainfall increased, it became say 20. So I will say 20 meter cube per second. And likewise, suppose this is increasing 30, then 40, 50, then 60. Then what happened? Again, the rainfall became slow. Uh, so it will come again, say 50, 40, 30, 20, likewise. So when I will draw the graph between the time and between the discharge Q. So suppose at time 0, there was nothing discharged. At time after 1 hour, what happened? Or I'd say at AM, then 9 AM, then 10, likewise. So we will see that it was that 10, then 20, 30, then 40, and 50, and then again it is reduced. And when I will join this line, then this graph will be called as the hydrograph, discharge hydrograph, right? Hydrograph. Hydrograph means what? Whatever the rainfall is happened here, so this rainfall is happened in the watershed, and through this stream, this water is collected at its outlet, and at its outlet we measure this Q at different time interval, right? Suppose at 8 a.m. and 9 a.m., then 10 a.m., then 11, then 12, right? We measured the discharge, that is 10, 20, 30, 40, 50, likewise. Then 1 p.m. again it is reduced, then 30, 20, 10, likewise. So we measured actually the discharge with respective time, and we draw the graph, time versus discharge Q, right? And we draw on the graph. This graph is called as the hydrograph. Is this okay? Hydrograph is clear now? What is hydrograph? What is the stage hydrograph? Okay. Now, this is the same thing is given here, whatever I have talked here. See, once we know that we know that the data from last many years, then we just predict this, whether it will go exactly straight or it will go some down level, or it will be after a certain period of time it will be constant and then it will reduce. So this can be predicted with different methods. So we can predict, or we can, after prediction we can say that uh, whether it will be whether it will increase or it will be just stopped or it will be constant. So we can do this with these two methods, logarithmic method and Chase's method. So we will not go into that detail. Just remember that whatever, see, based on the data, we had the data of say from 0 to 6 hour, whatever the discharge collected, right? Or height collected. Here we are talking about height, stage discharge measurement, right? So here we are talking about stage discharge measurement. So this can be predicted with these two methods. So during the event of the large flood, it is impossible or impractical to measure the discharge directly more often. So the flood stage goes beyond the range of the data. So what he is saying, when the flood comes, we cannot measure the discharge directly by just reaching to the river side. We can just measure only the height and at what height means what is the, we can say, what may be the discharge, right? This is only the stage discharge relation. I think it is clear to you. This stage discharge relation is clear. At particular height, what is the discharge of the river? This is river. What is this height of water, and whatever the quantity of water is there, that is called as Q. When we will draw the graph between these two, Q is on x-axis and H height is on y-axis, we will get some graph, right? So this is what is stage discharge relation. I, I hope it is clear. Is it clear? Now we are coming to another part, that is hydrograph. Hydrograph we have already seen. I will explain it some more. See what I told you. Suppose this is our, see, this is catchment. Already we have cleared it. What is catchment? Catchment means these are the lines which is having the same elevation, right? And if we will see this catchment, it will look like this. See, these are some hills. This is the top, we can say reduced level or top level of two hills. And whatever the water which will come inside, right? And there may be the another hill, right? There may be another hills. So here we can say valley or whatever you say, wadi. So whatever the water comes, this will be only in this area, right? Which will be only in this area. So this area is nothing but this one, right? This area is nothing but this one, and that is called as the watershed, right? Now watershed is clear. What I told you, there may be the number of streams, right? This is one stream which is coming directly at the outlet point. This is my outlet point, or we can say this is the point where the water is collected, and there are some other small rivers which are joining to the main river, right? So by traveling to this small rivers, water comes at this point. So when the water comes at this point, the discharge is measured from what I told you, that for example in the morning 7 a.m. it is started to the up to the next 7 a.m., right? Or 8 a.m. we can say 8 a.m. to the next day 8 a.m. A person will go, or if it is automatic, then again that can be measured at every time of interval. Suppose at 8 a.m., then what I can say 9 a.m., then 10, 11, then 12, and likewise again up to the next 8 a.m. Next 8 a.m. means this is uh, 7 p.m. for example, and the next, if we will come again, it will come not 7 p.m. This is 7 a.m. right? Means almost after 24 hours, we are collecting the water here. How much quantity of water is passing? So this is say water is passing at this outlet. Suppose this is my river, right? This is my river. So if I started in the morning 8 a.m., I noted down the discharge was say 1 meter cube per second, then 9 a.m., then 10 a.m., and likewise up to 7 p.m. and again 7 a.m., or we can say again 8 a.m. means almost 24 hours. We noted down the discharge 1, 2, 3, 4, 5, 6, likewise, right? And we will draw this into the graph. This time we will take on x-axis, on y-axis That will be what? That will be my discharge, that Q. This will be Q in meter cube per second. For example, in the morning, say 0, then we can say we started at 8 a.m., right? 8, then 9, then 10, likewise. For example, up for 24 hours. At 8 a.m., there was suppose 1 meter cube, then 2, 3, 4, 1, likewise. 1, 2, 3, 4, 5, likewise. So we will just join this graph and again it will come down. So this graph will be called as the hydrograph, right? And this hydrograph is where we are noting, reading, and for so this hydrograph will be for that particular river, right? If it is, see, this is catchment and one river is flowing. So for this river, this is my hydrograph. Right? Is this okay? Hydrograph is clear first. Please tell me hydrograph is clear. Hydrograph is just a graph that is time versus the q. So on x-axis we take the time t, that may be in hours or in day, and on y-axis we take the discharge, that is q in meter cube per second. When we will draw the graph between this, we will draw the graph. This graph will be called as the hydrograph. I think it is very simple. Now, again, there are some terms for this hydrograph. What are these terms? We will see here. I think I should go to the next slide so that there are the details given. Now, here first I will tell you the basic, then we will understand it. See, what I told you, the graph is generated this, right? From this portion to this portion, this is started, we can say at some points is not 0, but that maybe say 0 is here. That maybe say 1, then 2, 3, 4, likewise. So this portion is called as the rising limb. Rising limb. This one is the rising limb. Is this okay? Rising limb. Rising limb means if this is my hydrograph, from top to this portion, from where it is starting, this portion, right? This portion. This portion is called as rising limb. And from here to here, this portion is going down. That is called as falling limb. And from this peak where it is becoming constant, this portion is called as falling limb, right? And the top portion is called as the crest. This portion is what? This is rising limb, this is falling limb, this is the crest. Now here you will see that this point from where it is started and from where it has become some constant somewhere, right? This from here to here, and these points, they have joined, right? This is called as the base flow. The bottom below portion is called as the base flow. What is base flow? Base flow means what? When the rainfall started, some part of water goes inside, right? And it meets to the water table, right? When rainfall starts, this is when rainfall starts, what happens? Most of the water goes inside the water. That is infiltration, we can say, right? And here is suppose some water table. Then it water goes and meets to this water table. So what happens when the rainfall occurs? So immediately what happens? Immediately runoff does not occur. This is suppose my catchment and this is the river. And over this earth, when rainfall occurs here, and everywhere, it directly not flows into the river. Some part of water goes inside below this water. So this quantity of water is called as base flow, right? So here when you will see that this in the hydrograph, you will see that in the hydrograph, this much portion is neglected, means they will not participate in the they will not participate in the runoff, right? They will go directly down, they will go into the soil. Then after that what happens, then the remaining portion which is here, this portion is flowing, right? Is this clear? Base flow, direct runoff, recession limb. Recession limb is nothing, this same thing. And rising limb is this one. Rising limb is this one, which is the crest segment. Crest segment, we can say this is crest and these are the segments. Is this okay? Is this okay? Now I will come to some point. See how we come to know that this portion is base flow. So what happens generally when we prepare the graph? When we prepare the graph, this point from where it is, we can say the when it is started rising. So this point and where it has become almost it is going coming at constant level. When we will join this line, when we will join this line, the below portion we can get as a base flow, right? Base flow. And second one, you will see that the time of concentration is given. Time of concentration, and third one is lag time. Lag time means what? And time of concentration means what? See, this lag time means from where the water, this rainfall is started, right? And where it is coming down, this from here it is coming down. The time which is required for the water from the starting up to the stage of down. Just it is now, this is the stage has come, the down stage has started. We can say this portion is the portion where the graph is going down. So from this point to this point where the we can say the runoff, or we can say the discharge is started, this portion is called as lag time. Now another time is what? Time of concentration. Time of concentration means, suppose this is my catchment, this is my the outlet, this is my outlet, and this one is my the longest portion which is far away from the outlet. And I say that this distance is the longest distance in the catchment. Longest distance in the catchment, right? Now, what happens when rainfall was occurring? When rainfall was occurring, and you will see that after say 2 hour or 3 hour rainfall stops. So whatever the last particle of the rainfall is, suppose it was somewhere here, last particle, and after that the rainfall stopped. So the time required to travel the last particle from the end to the outlet, or we can say the time required to travel the last particle of the rainfall at the outlet is called as time of concentration. Is this clear? Is this clear what I told you? Time of concentration is clear? Time of concentration. Time of concentration means the last particle, suppose here is the last particle, and after that the last water particle which came here, and it was here, and rainfall stopped. So this last particle will travel from the ridge line up to this outlet. Whatever the time required to travel this last particle, then that time is called as the time of concentration. Just you assume that this is your class, and this is what I should say, the person who came late in the class, and he has to travel this longest distance up to the door, right? Or up to the last part of the class, up to the last corner of the class. Whatever the time will be required to travel that person to travel to the outlet, then that we will say that is the time of concentration. I'm just giving you example, right? Now, time of concentration is clear. Time, this is time based. This is called as time based. Time based means where this end point and out point is, we can say, has become constant. Now, what is this? This is time to peak. Time to peak means this one, from here to from where the rainfall started and runoff started, from this point, and it is, this was the point, and this point is, say, after 10 hours, from 0 hours to 10 hours, the this discharge, we can say flowing discharge, was at the highest peak, right? So whatever the time is required to reach the highest value of the discharge from 0, then that will, we will say that is the time to peak. The time from the beginning of the rising limb to the, we can say, to the peak discharge, that is time to peak. Time of concentration, we have seen lag time, we have seen time base is the duration of the direct run of hydrograph. We have seen this already. Now we will see this separation of base flow in the next class. Okay, will it be okay? And after that we will have some numericals. Then we will see these numericals, because numerical, what is this concept? To understand this concept is very important. What is this concept and how we can solve these problems. So here I stop. We will see this separation of base flow in the next class. Do you have any doubt? Salim, Meera, Ahra, Nadia. Okay. So here I stop, and in the next class, inshallah, we will cover some numericals, and we will try to cover some more. Will it be okay if I will record the another lecture and I will send to you, so that it will be easy to cover, because we have only now 4 weeks. So I will also take the live classes, but I will also record some more lectures, because we have very only 4 weeks, and we have to take some 1 or 2 quizzes also, and we have to cover the syllabus also. So I will record the lecture and I will send to you, right? Will it be okay? Can you speak, Salim, can you? Okay. What you're saying, but not more time is, can you speak? Salim, Mira, I'm not getting your voice. Okay. Okay, we will. I will try to record the lecture, and we will also cover in the live classes, right? So here I stop.